Hi, this is Team Robo-Erectus, team presentation video for RoboCup Asia Pacific Tianjin Invitational Tournament 2023 CoSpace Rescue under the University category. Our team consists of Owen, myself Jiele, Brian, and Hong Yi. We've worked on projects that are roughly based on robotics concepts and programming. Our previous RoboCup experience consists of refereeing and competing in auto delivery in RCAP Singapore Open 2023. This will be our first time competing in CoSpace Rescue Vision Challenge. The challenge requires a vision-based search and rescue robot to score the greatest number of points in dynamic areas, which requires an algorithm that can solve the following challenges: navigation based on detected surroundings, locating specific objects for collection using vision, best object collection combinations. Our strategies include image filtering using Gaussian and HSV filter. The noise reduction and filters allows better detection of objects and landmarks. We also try to employ image segmentation using SEM, Segment Anything Model. It helps simplify images into something more meaningful and simpler to analyze by enhancing the image dataset with segmentation masks on interest points, increasing the accuracy of localizing objects. The last strategy we employed was a point scoring algorithm which strategized what objects the robot should collect and when it's allowed to deposit them to score the most number of points. Next, we'll be going over the concepts of each of the strategies. Firstly, let's go over image noise reduction using Gaussian filter. The Gaussian smoothing operator performs a weighted average of surrounding pixels based on the Gaussian distribution to mute image noises, allowing details to stand out more clearly. However, after the addition of the filter, the results obtained weren't ideal and not what we wanted. The robot performed worse at detecting tokens and objects as the image gets distorted and loses sharpness. Thus, we decided to remove the filter. In the future, we want to experiment with more different Gaussian kernel sizes or other filters like bilateral filter, a non-linear noise-reducing smoothing filter for images that also preserves edges, which may require more computational power. Next, we experimented using HSV filter for image filtering. Using OpenCV, we set the HSV thresholds for different color objects on the field. The program then generates color boxes around their corresponding colors, which we can use to identify objects' coordinates from the camera. The results were, however, unsuccessful, as after many iterations, the program is still unable to detect and generate boxes for some of the red objects. Thus, we reverted to using HSL filter to detect color patches, as it is more intuitive and easier to create matching color thresholds using the CoSpace program. We also experimented with image segmentation using SEM. The Segment Anything model produced high-quality object masks from input prompts such as points or boxes, and generates masks for objects in an image. The segmented image can be used for precise navigation and allows easier detection of markers and objects. However, after running a sample program using VHSEM model, we realized it takes approximately 8 seconds to generate all the segments in an image, and it may not be suitable to be used for real-time computer vision processes. However, it still can be used to streamline annotating images to train object detection models. The last strategy we employed was a point scoring algorithm. The robot only starts searching for the deposit zone's April tag once it has collected at least one RGB combo to generate super objects for extra points. It can also only collect 2 of each object colors for chance of generating Super Plus objects for even more bonus points. Super and Super Plus objects have the highest searching priority. The robot will ignore objects and head to collect higher priority objects first. Our final results was that the robot was more dependable when locating and collecting objects. The robot also generates and collects Super Plus objects more reliably. The robot's final score increased from about 300 to 1100. Overall, we were unsatisfied with most of the results, and we believe we can do better. Further improvements can be done to the algorithm, and more strategies can be implemented. This is a demo of our program. As you can see, the robot can detect and collect objects using its vision. However, it does sometimes misses objects, as the objects were not sensed by its color sensors. The robot also has a hard time detecting and going to deposit zones, which are things we hope to work on in the future. Next, we'll be going over how the knowledge gained can be applied in the real world. Firstly, it can be used in self-driving vehicles to increase reliability and safety, which reduces traffic accidents and improves productivity. It can also be used in supply chain management robots, eliminating human error and streamlining processes to satisfy rising supply chain demands. Besides improvements to our previous strategies, our future will include applying CNN, convolutional neural network, to learn and analyze visual imagery for recognizing objects, classes, and categories. CNN requires very little pre-processing data compared to other learning algorithms. We would like to first try OpenCV's Surf, speeded up robust features for object detection and tracking. It's a sped up version of CIF with 3 to 4 times its computing speed, as it utilizes box filters for easier calculations.